Okay, this is the last lesson in this unit. Okay, so your goal today is I can sketch a graph of a parabola using the transformations from the equation. So we're starting with all the transformations. Okay, we have our translations, the H and the K, and we also have our vertical compression and vertical stretch as well. So we're going to look at a working example to start with. So here's our example. Y equals 2 bracket x plus 3 squared minus 4. Okay, so the first thing that we're going to do is we're going to look at, I need to plot the vertex, the h and the k. Now it's really important to remember that the sign of h is actually the opposite of the sign that appears in the bracket. And we talked about that and put a star beside that when we talked about that in that lesson. So in this case, when we look at it, we have a positive 3 in the bracket, which means I have a negative 3, which I didn't say correctly. So we have a negative 3, and our k is a negative 4. So we need to plot that first. So a negative 3, 1, 2, 3, negative 4, 1, 2, 3, 4. Then we have to decide whether the parabola opens up or down. Okay, and remember we do that by determining our A value to see whether it's positive or negative. In this case, it opens up because our A value is a positive number. Step number 3 is for the parabola. Remember, if there is no a, or the a is 1, I should say, or negative 1, there's no number in front of the bracket. In other words, we plot all the other points by moving away from the vertex in the following manner. And remember, this was the step pattern that I talked about before, in the sense that over 1, up 1 squared, over 2, up 2 squared, over 3, up 3 squared, over 4, up 4 squared, or over n, whatever n is for the number, that's the n squared. Now, in this case, we have a problem because we have an a value that's not 1, it's 2 this time. So what we need to do in this case is we have to take all those a values from before, and we have to multiply a by our step pattern from when it is positive 1. So what we're going to do is we're going back to our question, and we're going to our vertex. We're going over 1, up 1 squared times 2, 1, 2. Back to our vertex, over 2, up 2 squared times the a value, which is 2. So that means we're going up 4, we're going up 8. So we're going to go up 4. So there we go. Okay, and usually that's enough points to graph. Okay, and we're going to go on the other side and use the fact that parabolas are symmetrical through the vertex. Okay, so we have some nice points there, and now it's just a matter of drawing a nice smooth curve through them. And we'll see how I do with that, I should say. And back up. Not the greatest. Maybe I can try it again. That side's not too bad. Maybe if I come down to the side, that's still better than nothing. Okay, but it's really important that you do show those points, because even if you are slightly off on your graph when you drew your smooth curve, at least the person can see where those points are. All right, so that is how we can graph. Now, the other thing that we can do is I don't need to graph something. If I have the equation, I can tell an awful lot about it. Okay, so for instance, there's 5 main properties that we can find from the equation, and that includes its opening, its vertex, its axis of symmetry. In other words, if I folded the parabola in half, it's the same on both sides. Whether it has a maximum value or a minimum value. Remember, a maximum value means that the parabola is opening down, you can't go any higher. Minimum value means I can't go any lower, so that means the parabola opens up. And also I can tell the range. Now, I also know the domain as well. All parabolas are in the set of real numbers. So when we're talking about the domain of a parabola, it is always in the set of real numbers, unless they've done something really goofy on you. So let's take a look at our first equation. Okay, so the first thing I want to know, what's its opening? Does it open up or down? Well, I have this negative 2. So that tells me right away that I'm going to be opening the parabola down. My vertex, I have a positive 5 in the bracket, so that means it's a negative 5, 9. Axis of symmetry is always the x value of my vertex. So in this case, it is negative 5. So x equals negative 5. Because the parabola opens down, I know that it has a maximum value, and that maximum value is always going to be the y value of the vertex. So in this case, the y value is 9, and the range means it's going to be at 9, and because I'm opening down, everything has to be less than 9. Okay, so y has to be less than 9. Now we have to go y is the set of real numbers such that y is less than or equal to 9. Okay, now let's look at the next example. This time I have 1/3 and then my bracket minus 4. This time my 1/3 is positive, so I know that I'm opening up. I know my vertex, this time it's a negative in there, so that means I have a positive h value, and my y value, my k value, is negative 4. Axis of symmetry is always the x value of the vertex, so x equals 2. The maximum or minimum value, well, this time because it opens up, it means it has a minimum value, and the minimum value is always going to be the y value of the vertex. So in this case, it's going to be negative 4. And my range this time, obviously, y is in the set of real numbers, such that this time y always has to be greater than negative 4, because that's the lowest it can go. So that means it always has to be greater than that. Finally, the last one of this type of example is 10x squared minus 8. Well, it's positive 10, so it means I'm opening up again. My vertex, this time I don't have anything in with that x, so that means it's 0. And I have a negative 8 for my k. So my vertex is 0, negative 8. Axis of symmetry is always the x of the vertex, so x is 0. And the maximum or minimum value, well, this time again it opens up, so therefore I have a minimum value. It is always, the minimum value is always the y value of the vertex, so that is negative 8. Again, y is in the set of real numbers, but because y cannot go lower than negative 8, all the values have to be greater than that. All right, so you can read all that type of 5 pieces of information just from the equation. Now what we're going to do is another way, done very similar, but this time it is done in a table type thing. Same kind of thing, other than I put the vertex first rather than the opening. So the vertex here, so a positive 5, so that means we have a negative 5, and a negative 7 is my k. I have a negative in front of the bracket, which means it's going to open down. I also has the axis of symmetry is always the x value of the vertex, so that is negative 5. Because it opens down, it has a maximum value, and that maximum value is negative 7. And the other thing we know is we have y's in the set of real numbers. Now, because we have a maximum value of negative 7, that means everything has to be less than negative 7. The next one, x minus 1 is in the bracket, so I know my x value is positive 1, and my y value, my k value, is a positive 6. I have a negative 2, so again, it also opens down. My axis of symmetry is the x value of my vertex. Maximum value, because I'm opening down, and it will be the y value of the vertex. And I know that I have the set of real numbers such that because my maximum value is 6, I can't go any higher. It means everything has to be less than that. So y has to be less than 6. And actually, if I go back up here for a second, I have that it opens down. So actually, this number, this here should be y has to be less than. Just hold on a second and I'll change that. I'm wondering if any of you got that. So it has to be less than -7. Okay, now look at the next example. We have 1/3 and the x has been opened up, so it's going to be a +9. Nothing's been added or subtracted, so that means it's 0. It opens up this time. We have an x value for axis of symmetry of 9. This time, because it opens up, we have a minimum value, and it is going to be of 0. And our range this time, y is in the set of real numbers such that it has to be greater than, because I've got a minimum value, so it's got to be greater than 0. The next one, this time there's nothing in with the x squared, so that tells me that I have to have 0 and I have a +4. I also know that it opens up. Its axis of symmetry is the x value of the vertex. And it's because it opens up, it has a minimum value of the y of the vertex, which is 4. Again, y is in the set of real numbers, and this time y has to be greater than 4 because 4 is the lowest it can be. The last two here, let's look at this. -1/5 x squared. So I have nothing in with the x. I have nothing added or subtracted, so my vertex is 0, 0. It opens down because the a is negative. Axis of symmetry is 0, which is the x coordinate. Because it opens down, it has a maximum value of 0. And the range, y is a set of real numbers such that y can never go higher than 0, so it has to be less than 0. Then if we look at the very last question, there's something in with the x, so it's the opposite sign, so it's a -7, and -12 is our y value of our vertex. It opens down. We have x is going to be -7 for our axis of symmetry. We have a maximum value because it opens down of -12. Our range also is a set of real numbers, and we also have that it has to be less than -12. Okay, so I don't have enough time to do a graphing, so I'm going to stop the video and I'll do a couple of the graphs, and then you get to have some chance to practice. Okay, good luck.